Hello everyone, welcome to Exampreptool Placement Series Bootcamp 5. So in this Bootcamp 5, I'm going to solve one of the famous problem of computer science, that is check if given graph is bipartite. So what it means, let's see little more elaborated way I written, right? Let's see further, right? See this one. Given a graph with V vertices and edges, the task is to determine whether the graph is bipartite or not. Let me explain, first of all, what is the bipartite graph? Let me explain. So one example I'm taking, example. So A, B, C, D. What is the algorithm? Afterwards we will see. First of all, what is the bipartite? Let me explain. So this graph is bipartite or not? Let me check. So what you do is, what is the meaning of bipartite is, you have to divide the given graph into two parts. So you start from anywhere. Let us assume that I started with A. I started with A. Understand? So start with any vertex. Whatever vertex you want, you can start. I started with A. Now, when you started with A adjacent, who are those? B and C. A adjacent is B. A adjacent is C also. Remember, if A is there in the M group, A adjacent should be there in the N group. That is the meaning of bipartite. If you keep A in the M group, right, their adjacent, A adjacent should be there in the N group. If you can keep all the people like this without any ambiguity, then I can say it is a bipartite graph. Okay, I think A adjacent people are B, C in another group, so these are completed. These are completed. Now let's go to those edges which are not completed. Right, I think D, right, those vertices which are not completed. So I think so these edges are, two edges are left out and one vertex also left out, right? Let's see our goal is all edges should be covered. All edges should be covered. I think E1 edge covered, E2 edge covered, E3 left out, E4 left out. Yeah, I want to cover E3. So who is the E3? C to D. Remember, C here, D should be here. So this is also completed. I want to cover E4 also. E4 means B to D. So remember B here, D. So if you want, you can verify. If two people adjacent, right? One person is there in the M group, another person is there in the N group, right? At the end, if you observe, all vertices are covered, all edges also covered. There is no ambiguity. So given graph is a bipartite graph. So given graph is a bipartite graph means without any ambiguity, you are able to cover, you are able to decide is a bipartite or not. It is a bipartite graph. Given graph is bipartite graph. Now, if anyone having little doubt also, let's take one more example. Let's take one more example. A, B, C, D. A, B, C, D. Let us assume that one more edge I kept like this. So edges are, if anyone having small doubt also in the above explanation, you can see this E1, E2. Remember all edges, all vertices, everything should be covered. Total graph should be covered. Not only vertices, right? Edges also should be covered, right? So at the end, all should be there, right? The graph which you are going to draw. So E5, E3, E4, E5. Yeah. Start from any vertex. You have to divide the graph into two parts. Name itself saying bipartite. M group, N group. M group contains some vertices. N group contains some vertices. Start from anywhere. I'm starting from A. So A adjacent is B and C. And interesting thing is A completed, A adjacent to E1, E2 completed. Remember all vertices, all edges you have to cover. E1, E2 over. Let's go to E3. E3, if you observe BC. So I think this is the real issue. Listen, this is the real issue. If you go to the E3, which is the BC, see this one, BC. Within the N group, you cannot keep. Always, if two people are adjacent, one should be M group, one should be N group. If two people adjacent, you cannot keep in the same group because of this, not bipartite. No need to proceed further also. Because of this, it is not bipartite. If two people adjacent, one person will be M group, one person should be N group. Remember, if two people adjacent, they cannot be present in the same group, right? But unfortunately, B and C are adjacent, they both are in the same group, so it is not bipartite. So this is the bipartite problem, right? I hope everyone is fine. Some people are asking how to solve this problem, right? So I think it's a very interesting, very interesting how to solve this problem is because of it's a very simple one. There no much work is there. Just traversing the entire graph one time. You can solve this problem using BFT also, using DFT also. BFT also, DFT also, both you can do. Both you can do. BFT using breadth first traversal you can do, using depth first traversal also you can do. So I will do one automatically, DFT you can do by yourself. I will do BFT, you can do automatically DFT also, right? Let's start this. Let's start how to solve this problem using BFT. How to solve this problem using BFT, right? So I'm trying this. I'm trying. Careful, careful everyone. A, B, C, D. Everyone observe. Using BFT, how you are going to do it. Using BFT, how you are going to do it, I'm going to explain here. So A, B, C, D, right? A, B, C, D. So what is the first thing you will do is, all the vertices which are present in the given graph, take one array, name is called widgeted array. Widgeted array. Take one array, widgeted array. You can give whatever name you want. So widgeted of A, widgeted of B, widgeted of C, widgeted of D. If at all more people are there, you can take more people also, no problem. More people are there, you can take more people also. Let me try some more people. Let me try some more people. So maybe only for name's sake. E and F. E and F. D, E and F. So widgeted of every person initially -1. Widgeted of every person is initially -1. That is the first step. Widgeted of every person initially -1. So understand. Okay. So now start with the A. Right? I'm starting with A. So according to BFT algorithm, if you start with any vertex, keep that person inside. Keep that person inside the queue. BFT uses queue data structure. Keep that person inside queue. So I kept A inside queue. But remember, before going to keep A, ask what is the A color. Keep the A inside the queue, okay? Before going, ask what is the color of A. If color of A is right -1, means color means widgeted. Widgeted of A is -1. Widgeted of A is -1. If you want, you can change the name also. In the place of widgeted, you can keep color. Whatever name you want, you can keep. No objection. Yeah. So color, COLUR, I think so. So color, right? Color of any person is initially -1. Color of any person is initially -1. You can write widgeted also, no objection. Names doesn't matter. Whatever name you want, you can keep. So before starting any person, you want to start from A, ask what is the A color. A color is -1. So what you do is, right? You can keep any color. Let us assume that this color is 0. If -1, make 0 and keep that person inside. I took A color is initially -1. I kept 0 color. Okay, fine. So I kept. Now what you do is A, right? A color is 0. I kept inside also. Now what you do is delete A from the queue. Delete A from the queue, right? So I deleted A from the queue. Ask all adjacent who are those. Ask A adjacent all who are those. A adjacent all those are B and C. So ask them, A deleted, right? A deleted, that's okay. A deleted, fine, perfect. A adjacent, who are those? Find out B and C. A adjacent, who are those? Find out B and C. So A adjacent is B and C. Then immediately ask, what are the B and C colors? Then ask immediately what are the B and C colors. If B and C colors are -1, then what you do is keep the B and C inside the queue, right? If they are not visited, keep both of them inside the queue. A came out, A adjacent people will go inside. Because of they are -1, keep inside. But remember, if A color is 0, B and C, their adjacent people color should be different. So keep one. This is the approach. Means if A belongs to M group, their adjacent people are in the N group. That is the meaning. Because of colors, we are thinking maybe 0 and 1. Right? Very simple. If anyone is not getting exactly, I'm doing BFT. Exactly, I'm doing BFT. Same story continue. Same story continue. Some people are asking, well, how the same story? Let's start. Once again, delete B. Once again, delete B. Okay, I deleted B. Previously A deleted. Now I deleted B. As soon as B deleted, immediately find out who is B adjacent. As soon as B deleted, immediately find out who is the B adjacent. B adjacent is A and D. A already visited, so A already see. A already, if A, otherwise you can see like this also, no objection, right? So B deleted, who is the B adjacent? Find out. B adjacent is A and D. B adjacent is A and D. And remember, B color is already 1. B deleted, B color is already 1. B adjacent is A and D. Immediately check. B adjacent is A and D. Immediately check. B adjacent is B color is already 1. B adjacent is A and D. B adjacent is A and D. So immediately ask, hello A, what is your color? If -1, I will keep inside the queue again. But is not -1. What is the A color? 0. So B is 1 color, A is 0 color. So because of is other than, right, is not -1, you no need to keep inside. And one more, they are opposite also, no problem. Opposite means no problem. Because of it is not -1, no need to keep inside. So new people only have to keep inside. He is a old person. How you know? It is a right, its color is 0. So he is a old person. Because of old person, no need to keep inside. And one more, it is opposite also, no problem. So leave it. Next one, B adjacent D also. Immediately ask, hello D, what is your color? D color is -1. Oh, he is a new person and is adjacent also. Then what you do is, because of new person, keep in the queue, but keep opposite color. It is a 1 means it should be 0. So this one should be 0. B1 means, right? Keep the D0. So like that. Immediate in the similar way, C also. If anyone is not getting, at least you follow from now onwards. At least you follow from now onwards. Now C is coming out. Whatever way B came out, C also came out. Now see this one. C is came out. Who is the C adjacent? Find out. C adjacent is going to be A also, D also, right? And one more E also. An important thing is, what is the C color? What is the C color? Sorry for this. Sorry for this one. C color. I think if you observe clearly, previously B color is what? B and C color is 1 1. B and C color is 1 1. D is D0. Okay. D0. Yeah. Sorry for that. Now let's start now. Those people who confuse a little bit also. Little bit also. If you confuse, don't worry. I am at C. This is the current status. Whatever happened, happens. Just leave it. At least from now onwards, you can follow. I am at C now. I am at C now. So this is the current status. What is the C color? 1. What is the C color? 1. Right? Who is the C adjacent? C adjacent is A also, E also, D also. C adjacent is A also, E also, D also. Then immediately ask, hello A, what is your color? Hello A, what is your color? A color is 0. 0 means already visited. But and one more, 0, okay. Is it opposite? Yes, no problem. Next one, hello E, what is your color? E said -1. Oh, -1 means new person. New person, right? New person. Keep at the end of the queue, but keep his color as opposite to parent. I think C1, it should be 0. If C parent is 1, it should be 0. So it should also be 0. In the similar way, go to the D. Hello D, what is your color? Hello D, what is your color? So D said that my color is 0. 0 means already visited. No need to keep inside because he may be already there. No need to keep. But what is your color? 0. Opposite, no problem. Opposite, no problem. So like that, it will keep on continue. Go to the D now. Almost you done it. Almost you done it. Almost you done it. Now I am at D now. Don't confuse. Now I am at D now. As soon as D came out, D immediately asked, who is my adjacent? D adjacent is C, D adjacent is B, D adjacent is F also. But D color already, if you see the D color already 0. D color already 0. D color already 0. Now D is asking all adjacent people C, B, F. Hello C, what is your color? C said that my color is 1. So my color is 0, your color is 1, no problem. This right other than -1 means visited. Now D is asking B also, hello B, what is your color? B said that my color is 1. So I think right 1 means it is visited and the opposite no problem. So D is asking, hello F, what is your color? F is saying that my color is -1. Oh, not visited. Because of not visited, visit means keep inside. Because of not visited, visit means keep inside, but give opposite color. Give opposite color. If D having 0, keep 1. Right? In the similar way, F, E also will go. In the similar way, E also will go. So E will ask, right? E will ask, who is the E adjacent? E adjacent is going to be only C. E adjacent is going to be only C. So E color is already, what is E color already? E color is already 0. F color is, I think, 1. F color is already 1, right? This is the current status. So I am at E now. So E color is going to be 0. E adjacent is what? C. So E C, what is the C value? What is the C value? 1. So E adjacent is C. E adjacent is C. E color is, I think, 0. Let's check. What is the E color? 0. E adjacent is what? C. C color is what? 1. So no problem. Because of it is other than -1 visited, opposite, no problem. So I think nothing will be added by E. So in the similar way, F also. F also nothing will be added. At the end of the day, Q will be empty, stop it. F also similar story will happen. So means what I want to say is every time opposite required. Suppose -1, you can keep whatever you want. If not -1, please check opposite or not. See opposite. If parent is 0, children are 1. If the parent is 1, children are 0. If the parent is 0, children are 1. Suppose initially what happened is if the parent is 1, children may be -1, right? If whenever -1, you have liberty because they are not visited. So visit them. Visiting in the sense, keep the color to them, keep in the Q also. Remember, BFT, we are using Q data structure. BFT, we are using Q data structure. So Q means NQDQ. Q means NQDQ. Whatever language you want, you can write, no objection. Using BFT, you can do. What is the meaning of BFT? A followed by A adjacent all the people. A followed by A adjacent all the people. A followed A adjacent what? BC. See, A is went out. Their children's BC came. Right? B is went out. Their children's which are new people, D came. Actually, B adjacent is going to be AD. A already completed. So no need to take the same person again and again. So graph traversal BFT, DFT. If same person coming again and again, they don't take. New persons only they will take. So inside this queue, whatever I am taking, every person will come once only. Please check. E came once only. Right? F came once only. Every time, right? Every vertex will come only once. Because of it is a traversing a graph, just I traverse the graph using BFT, time complexity, using list V plus E, using adjacency list, time complexity V plus E, because one time visiting, using matrix order of V square, adjacency matrix V square, and one more extra space, one Q I taken, which will take order of V space. If you want visited array, one more V, totally order of V plus V, 2V, which is nothing but order of V for the Q, V for the right color array purpose V, Q purpose one more V, totally 2V, which can be written as big O of V. So using BFT, this is the story. Simple, very simple, just BFT. I'm simply saying simply BFT. Simply BFT. Other than this, nothing. So you can use, I written one Python program also. Roughly, I written the Python program also. Right? See this one. So this is the main program. From main program, I called is bipartite of V. I started from some vortex. Is bipartite of V. So if you go inside, initially color array initially is all are -1. Right now, take the one person, right? Take the one person. Starting vortex assume that 0. So I started with that. Right? See, one person you take, asking what is the color. If color is -1, keep 0, keep inside the queue, then start. Right? So while queue is not empty, delete that person. Whoever adjacent find out, ask everyone what is the color. If color is -1, keep the parent opposite color. Right? Add at the end of the queue. So continue. Right? At anywhere, if you see mismatch, parent and children's color is same, then say that it is not bipartite. So this is the place where all the adjacent people will be added. All adjacent people. If you take one person, see whoever you take, that person you delete. All adjacent people you find out. If -1, keep whatever color you want, and add also. If -1, keep whatever. See this one. If minus one, whatever is the parent color, keep opposite color. Then add him at the end of the queue also. Add him at the end of the queue also. Right? Just keep on continue at anywhere. Parent color, children's color, parent color, child color, same. Then stop and say that it is not bipartite. Return false. Here false will come. Otherwise, return true. Right? One for loop, one while loop. Right? One for loop, one while loop. Right? This while loop will take care about what he says. This for loop will take care about edges. So finally, time complexity. Matrix V square. Adjacency matrix. If adjacency list V plus E. Adjacency list. Simply Python program. You can write whatever language you like. I hope you got it. Right? If anyone got any small doubt also in the comment section, you can comment. I'm going to help you. Thank you so much. I started with the problem itself. What is bipartite? I given 2 examples followed by how to find out using BFT. I done. So the homework to you will be just to do DFT. Same story. We were using here Q. In the DFT, you will use stack. DFT uses stack data structure. BFT uses Q data structure. Right? Remember, if the parent having some X color, right? So children should be there other than X color. Here only 2 colors I am taking, 0 or 1. If the parent having one color, if the parent having color 1, right? Children should be there 0. If the parent having 0 color, children should be 1. If it is a -1 starting, you can keep whatever you want. If not -1, check opposite color or not. So continue like this. At anywhere, parent and children both are similar. Stop and say it is not bipartite. I hope you got it. Little doubt also there. Please comment in the comment section. I'm going to help you. Thank you so much. Right? See you in the next session.